All right, we're looking at quadrilaterals and we're deciding, is that quadrilateral, is that four-sided polygon, is it a parallelogram? That's the whole idea today. Is this quadrilateral a parallelogram? Well, I'm going to give you a list of things, coming at you with some facts, and if one of these things is true of a quadrilateral, then that quadrilateral is definitely a parallelogram, and that means that all the other facts must be true. First one, both pairs of opposite sides are parallel. This is pretty obvious. This is the definition of a parallelogram. If both pairs of opposite sides are parallel, then yes, that quadrilateral is a parallelogram. If both pairs of opposite sides are congruent, so we don't even have to know if the sides are parallel. If we have a quadrilateral where the opposite sides are congruent, definitely a parallelogram. If both pairs of opposite angles are congruent, so we don't have to know anything about the sides besides the fact that there's four of them. And if we have two pairs of opposite angles that are congruent, it must be a parallelogram. If just one pair of the opposite sides are congruent and parallel, so you don't have to know anything about the other two sides. If one pair of opposite sides is both congruent and parallel, that's enough to say this is a parallelogram. Finally, if the diagonals of our quadrilateral bisect each other, this is definitely a parallelogram. So once again, we have a quadrilateral. If any of these things is true, that means that shape is a parallelogram, and that means that all the rest of these things would have to be true. So, looking at this real quick, we are told that these sides are parallel. We're told these angles are congruent. We want to know, is this a parallelogram? Well, right now we only know about one pair of opposite angles. We only know that one pair of sides is parallel, so just at first look, we don't have enough information. But if we go a little bit further, and we realize that those angles must be congruent because they're alternate interior angles, and then we realize because they share the side, these must be two congruent triangles, and therefore, by corresponding parts, congruent triangles being congruent, that angle must also be congruent between the two. So we really know that this whole angle is congruent to this whole angle down here. So we know that these angles really must be congruent, and so therefore we do have two pairs of opposite angles that are congruent, and I say yes, this must be a parallelogram because of that. So we had to think about it a little bit more than just looking at the facts we were given. Taking a look at this one, we've got quadrilateral PQRS. We're told that these opposite sides are congruent. We want to know, is this a parallelogram? Well, if these opposite sides are congruent, we can set 3x plus 2 equal to 5x minus 38. These expressions must be equal. We can solve for x. We get 2x equals, negative 2x equals a negative 40. So x would equal 20. And then I can plug it in and look at these angles. This angle here must be 60. This one would have to be 120. When we plug it in right there, we get 60. Down here, we get 120. Look at that. The opposite angles have the same measure. The opposite angles are congruent. And if we have two pairs of opposite angles that are congruent, that quadrilateral must be a parallelogram. Okay, next one. In this quadrilateral, J and M are supplementary, and these opposite sides end up being congruent. Is this a parallelogram? Well, with that supplementary fact, we don't know how that relates to these other angles, because if these are supplementary, we know that these over here are going to be supplementary too, but we don't actually know if 2 is going to be congruent to 4 or one's going to be congruent to 3, just based off that information. But we do know if those two angles are supplementary, those are same side interior angles when we have two lines cut by a transversal. And if same side interior angles are supplementary, that means those lines are parallel. So we have one pair of opposite sides that are both congruent and parallel. So yes, this is a parallelogram. Here, once again, we have a quadrilateral. Is it a parallelogram? Well, we see that these sides are congruent. So I know then that 9 must equal 2x plus 3. I can solve for x. Since x is 3, now I can plug it in and see that that's going to be 6, that is 6, that is 7, down here that is 7. So notice the diagonals have been cut in half where they intersected. The diagonals were bisected. If the diagonals of a quadrilateral are bisected, yes, this is a parallelogram. Here, Gardner wants to know how much fencing to buy for the perimeter of her garden. The garden has two paths that bisect each other to form an X. How much fencing does the gardener need? Well, if two paths bisect each other, here's the paths. The paths are diagonals. They have bisected each other. Well, that means this quadrilateral is a parallelogram. And in a parallelogram, all those other facts are congruent. The opposite sides are congruent. So they have the same measure. We can use that and we can add this up to get the perimeter, which is 28 yards.